Now we are going to look at the key operation of simplex. That's how a simplex algorithm executes, which is called pivot operation. First, I have to understand what is pivoting. Okay, so let's suppose the current assignment B violates a bound in a basic variable. Then simplex correct it by pivoting. Pivoting means it changes one variable which is basic and turn into a non-basic variable, and another non-basic variable is turned into a basic variable. Let's suppose J is a, by looking at it, since it has exactly 1 minus 1, so it's a J is a basic variable, it's an element of the basic variable. I is a non-basic variable. And what do? I will swap them. How do I swap them? Is basically row operations. In the row operations are done such that -1 comes here, 0 0 0 everywhere, and whatever the consequence of this row operations on this column is, and so whatever it may be. Okay, so if we do these kind of row operations, we obtain this kind of matrix. Okay, so this swaps the role of variable I, xi and xj. J becomes a non-basic variable and I becomes a basic variable. So there are three variables involved here. One variable that gets violated, then we choose a non-basic variable that needs to be swapped, and then we choose a basic variable that will swapped with. So we will need to find three variables. Please note that the violated basic variable does not participate in pivoting. The other two variables participate in pivoting, and we will show you first find the violating ones, then find this guy, and then find this guy. So without loss of generality, assume that the first column is my basic variable and it is being violated, and the -1 is also sitting in the top corner. It's just it's a fair assumption to make for the ease of representation, and its upper bound is violated, u1 is violated. So we need to decrease vx1, we want to bring it down. Okay, how do we do that? So we call vx1 minus u1 violation difference. This much violation has happened for x1 and I want to get rid of it. I want to decrease vx1. Write other cases that are ignored due to without loss of generalities. Whenever we say that without loss of generalities, it means I'm talking about a specific case. What other cases has been ignored? It's a good exercise to see what are the possible cases and how to write them down formally. Since x1 is a basic variable, it must have a definition in terms of non-basic variables, and we need to change the value of this non-basic variables because their values were chosen and x1 got fixed, right? So we need to change their values such that that x1 decreases. We do not change all the variables, we choose some xi, okay, such that a1i xi decreases. So we say an index I in among the non-basic variables is suitable if xi is unbounded. If there is no bound on xi, then what can you do? You just you can change your xi whatever way which you want, and then it's fine. It's suitable choice. Okay. What on the hand, the current value of xi is an upper bound. Okay, so current xi, let's say xi has a range, some range, say the ui to li, and this xi has currently sitting in the upper bound. Remember that if you have a bound in the non-basic variables, they are either sitting at the upper bound or they're sitting at the lower bound. So this guy is sitting in the upper bound, so now it can be decreased, right? So, and this coefficient is also positive, so both together will decrease. Okay? So if you have an upper bound and your the coefficient is positive, then you have a scope of sort of helping out x1 to reduce its violation difference. If your coefficient is negative, then you're sitting at the lower bound, you can be increased, and therefore this whole term can be decreased. And again, you can help x1 to reduce its violation difference. So what do we do? There may be multiple choices, there may be no choice. Let's suppose there is some choice. Okay, so if there is no choice, then we are stuck. Algorithm gets stuck, it says unsatisfiable. If it is a choice, then so what happens is that there can be multiple i's that may satisfy the suitable condition. Among them, whichever has the minimum index, we choose select that. Okay? Call it a selected suitable column, and this will become non-basic variable, which will leave the non-basic set and join the basic set. Now we need to find the basic variable with which it will be pivoted. Let's look at an example. So this is in this case we have, these are the basic variables and these are the non-basic ones, and all the non-basic ones were unbounded, right? So they are all suitable ones. So which one will be suitable? Which is minimum index. So this guy will be my selected suitable column. Okay, so I equals to 3. Now let's try to get the intuition. Okay? How I'm going to choose the basic column to pivot with this non-basic symbol. Okay, and how it is going to help me, to reduce the violation difference. So since xi appears also in the definitions of the basic variables, right? So all non-basic variables appear in the definition of other basic variables. So if we change value of xi, that was the way we are going to decrease the violation difference, it may lead to some other violations, right? For example, in some xj, which is a basic variable, let's suppose I appears there, and so it must have some coefficient there, okay, which is this y, okay, and there will be other non-basic variables. Okay, this is just hanging around, it remains same, it doesn't change. So but the important point is this. Okay, if this coefficient is non-zero, okay, not equal to 0, if change in xi will change xj, and maybe xj has bounds, okay? And if you change too much, you go out of its bounds, and it's not allowed. So there will be, every basic variable must be putting some restriction how much you can change. But important thing to observe, we had the principle of single violation earlier. So at any given time, there is exactly one violation. Because of that, we already have one violation which we're trying to correct. Therefore, no other basic variable must have violation. Therefore, current xj must be within the range. Okay, so now we are in this state when then we want to make a change in xi, but other basic variables is not letting you move. So let's figure out how much they are letting you. Okay, so try to understand how much a basic variable. Let's look at this expression again, which we have been seeing in the previous slide. And now let's say if akj I is greater than 0, if we increase xi, it will increase xj. Okay, if we increase this guy, increase xj, and this much we can increase. Look, take the upper bound of uj, okay, and the current value of vxj is this, right? So how much you can go up to the upper bound, and take this much and divide it by the coefficient. This much delta you can create in xi. Okay, this much xi can be changed to push it up such that xj go up. Okay, now let's see how we're going to find which index allows the minimum change. Recall our example, we had this x1 which was stuck in which is upper bound was being violated, and in its expression you had a 1i xi, and if this guy is negative, okay, and I want to decrease this guy, okay, x1 needs to be decreased, then I need to increase xi. How do we increase v of x? How much we can increase vxi? That is the question. What do? We basically go over all the basic variables. Okay? If their coefficient for I is positive, I see how much it allows. Okay, if the coefficient is negative, then you check how much it is allowed from the lower bound. Okay, and we collect all these changes and say, okay, which one is the minimum change? Whichever basic variable is forcing me to allows me the minimum change, and choose that j. Okay, that basic variable that allows me to the minimum change. That guy will become my choice for the pivot. Okay, again we have stated something called without loss of generality. Basically this I said less than 0, it can be greater than 0, so please check how this will change for greater than 0 case. Okay, So let's go back to our example. So we change x, which is third column, right? Selected suitable column, to reduce the violation difference. Since my vy, the value of y is 0, so if you look at the definition of my basic variable s1 and s2, it reduces to minus x and x. Okay? And x needs to be changed, and currently s2 is being violated. So let's plot it. If you change x, how it impacts the value of s1 and s2, and what ranges of values of x is allowed for them. Okay? So you plot it. So it's by relation between s1 and minus equals to minus x, and s1 is less than equal to minus 2. It says that if x has in this range, okay, I'm good. Now let's look at the s2 allows less than equal to 3. Okay, so if you ask s2, I'll say how much I can change. So s2 equals to x, then x should be less than equal to 3. So basically it says that x should be somewhere here. If you go x changed above this here, then I am very unhappy, I'll get violated. So by looking at it, you'll say, okay, from here, who is asking me that bounding my change? Okay, this guy is bounding my change. So I'll say, I'll go up to there and I will not go further. So it sets my x equals to 3. And then s2 also takes the value 3. Okay, so that's to be noted. So s2 essentially hitting to its upper bound. Okay. So what do we do? Let's suppose j is the in the variable. For example, in this case of s2, which is a part of the basic variable. Now it can be changed to hit its upper bound. So what you can do is that if that is the case, then you change the basic and non-basic, swap them, and once you swap variable, the overall constraints doesn't change. Okay, so it's just the role of the variable changes. So still the same set of satisfying assignment. But now j is a non-basic variable. Now you're going to choose the value of the non-basic variable, and you assign it its upper bound, which we have already seen. If you make it to the upper bound, nobody else gets violated. In fact, the total amount of difference, violation difference, decreases because of this swap operation. So there are other possible cases. One more possible case is that the amount of change allowed is infinite. Okay, and upper bound of your UI in non-basic variable is also infinite. So then what do? You just pivot between your violated variable and the I, and then you don't look for the third thing. So this is one special case. There's another case in which if their bounds exist for the variable I, in which you cannot violate beyond this, and the change is actually allowed more than the range of I. So this is okay. What I will do, that flip. So I was in the lower bound, then it goes to upper bound. If it is an upper bound, so go lower, whatever the right direction to go, you go, and then you change pivoting, and then you don't need a pivot. If the violation persists, we further do the pivot operation. We just go back and look for same violations, and then identify basic and non-basic, and swap them, and keep this process will keep decreasing your violation difference. At some point of time, you will become greater than equal to 0. What else can happen is that you may end up finding no non-basic variables that can improve your situation. Then you have unsatisfiability. So here is an example in which this guy as your I, when you did this up, then you analyze it, then you say, okay, my S2 is a swap, so this guy will be you swap your J to be swapped. Okay, so you pivot between 3 and column 3 and 2, and if you do that, this guy becomes part of basic variables, and these two becomes non-basic. Okay, and now you have a non-basic variable s2. Okay, s2 is non-basic. Then you choose its value. If it has any bound, it has a bound which is an upper bound, assign it to 3. And you can see, because of virtue of pivoting, now we satisfy.